Let's think about distance and midpoint formulas, starting with distance. For any 2 points, P1 and P2, the distance between them is calculated with this formula. I'm sure it looks familiar to you from algebra and geometry both. But let's talk about where it comes from. You may recall that it has something to do with Pythagorean theorem. Okay, so let's sketch in a right triangle. That gives us a new point, and we need to calculate the length of the legs to use Pythagorean theorem. Luckily, they're both horizontal and vertical, so we can if we knew the coordinates. So let's make up some coordinates. P1 we're going to say is at x1, y1. The subscript numbers just are a more descriptive way of using x and y. So P2, similarly, we're going to call it x2, y2. So that new third point is lined up with P1 and P2. Let's look at how. The x coordinate is lined up with P2, so I'm going to use x2. And the y coordinate is lined up with P1. So I'm going to use y1, and those are the coordinates of the new point. Now let's find the lengths of the legs. The horizontal leg from P1 to the new point could be found by just subtracting the x coordinates. Now for the purposes of this drawing, keep in mind that P1 and P2 could be located anywhere. We can't really assume that x2 is a greater value than x1. So when you subtract them, you might get a positive number or you might get a negative number. But distance is positive, so let's put some absolute values on there to make sure that it doesn't matter where our 2 points lie. This will still work. And the distance of the other leg from P2 to the new point can be found by subtracting the y coordinates. And similarly, we need absolute values to make sure that comes out positive no matter where P2 is located. For the Pythagorean theorem, we would then square both of those distances and add them together in order to get the square of our mystery number. I'm going to say this is the mystery distance right here, so that would give us the mystery distance squared. But we don't want the mystery distance squared, we want just the mystery distance. So we're going to take the square roots of both sides. So our mystery distance, which is also referred to as d for distance in most cases, is given by this formula. But this formula needs some cleaning up. Notice that in our original formula, there's no absolute values. Why is that? Well, you've probably already figured this out. When we square any number, we're going to get a positive result, right? So it becomes redundant to have both absolute values and squaring. But we definitely need the squaring to get the right amount. So let's change it to just parentheses squared. And the same is true of y, of course. There we go, and that's our distance formula. Now there's one other side note I want to make here. This might have set off some alarm bells for you when I changed it to just question mark. Normally, when we have the square root of a quantity squared, we say that that is equal to the absolute value of that quantity. That's because when we square it, if it was negative, it became positive, and when you take the square root of it, you don't know whether the original root was positive or negative. So we say that the square root of something squared is the absolute value. In this case, though, we're looking for distance, and distance is positive anyway. It isn't necessary to use absolute values in this case. And so there's our distance formula. And now when we use it, we simply take the coordinates of any 2 points and plug them in. When you plug them into this formula, the order of these two numbers doesn't really matter. When you square it, you're going to get a positive result anyway. So even though we usually write the formula with x2 before x1 and y2 before y1, that order really does not matter when you use the formula. And that's distance formula.